Ever wonder what's actually holding your core together under the surface? Well, welcome to the Explainer. Today we're diving deep into the anatomy of your abdominal wall. And whether you're studying out for an exam or you're just endlessly fascinated by how the human body works, we're going to break this all down in a really simple, straightforward way. We'll be peeling back the layers of your core, going all the way from the superficial surface down to the deep layers. Let's get into it. So let's kick things off with a pretty basic question. What exactly makes up the anterolateral abdominal wall? We throw the word core around all the time, right? But it's definitely not just one solid block of muscle. It is this highly specialized, incredibly dynamic network that protects your vital organs, helps push air out of your lungs, and literally powers almost every single movement your trunk makes. To truly get a handle on this, we need to clarify a couple of terms. First, the anterolateral abdominal wall. That's just a fancy anatomical way of saying the front and side core muscles. Simple enough. But we also need to talk about an aponeurosis. Now, an aponeurosis is basically a broad, flat sheet of tendon. So instead of thinking about a rope-like tendon that connects a muscle to a bone, imagine a wide sheet of biological fabric. It works a lot like the tightly pulled laces on a muscular corset, securing everything tightly across your abdomen. Looking at the overall layout of the abdomen, we have 5 distinct muscles that logically divide up into 2 main groups. First, you've got the 3 flat muscles that wrap right around your sides. And second, you've got the 2 vertical muscles running straight down the midline of your body. Together, these 5 muscles build the entire architectural foundation of your midsection. Let's start by unboxing that first group, the flat muscles. So starting from the outside and working our way in, we hit the external abdominal oblique. This is the largest and the most superficial of the flat muscles. And a really cool detail here is the direction of its muscle fibers. They run inferomedially, which is just a highly technical way of saying they run diagonally downward and inward. Honestly, it's exactly the same angle as if you were sliding your hands right into the front pockets of your jacket. This muscle is an absolute powerhouse. It anchors up on the outer surfaces of your lower ribs, specifically ribs 5 through 12. And when both the left and right sides contract at the same time, they act like a giant compressor for your abdominal contents. That increases the pressure inside your abdomen and actually helps force air out when you exhale. They also help flex your trunk forward. But what if just one side fires? Well, then it rotates your trunk over to the opposite side. Now here's where it gets super interesting. Tucked immediately beneath that external layer is the internal abdominal oblique muscle, and its fibers run superomedially, meaning they run upward and inward, which is perfectly perpendicular to the external oblique sitting right on top of it. By running in those opposite crisscrossing directions, these smaller, slightly thinner fibers build a wildly stable structural network. It's literally the exact same engineering principle behind the cross-ply layering in a high-performance tire. For its origin, the internal oblique attaches mainly to the thoracolumbar fascia in your lower back and the iliac crest of your pelvis. It then inserts up into the lower ribs, and its aponeurosis ends right in the midline. Functionally, it works hand in hand with that external oblique to compress your abdomen and increase pressure when you breathe out. If we break down how these obliques actually move you, there's a really important distinction between using both sides at once versus using just one. Like we said, bilateral contraction, both sides, flexes your trunk forward. But unilateral contraction of the internal oblique lets you laterally flex, or side bend, and rotate to the same side. That's a bit different from the external oblique, and it really shows how brilliantly these layers coordinate to pull off complex, twisting movements. Plunging down to the absolute deepest layer of the flat muscles, we find the transversus abdominis. And true to its name, the fibers of this muscle run perfectly horizontally, transversely, straight across your abdomen, from the sides toward the front. You really need to understand what this deep layer actually does, because it's crucial. Originating from the thoracolumbar fascia, the iliac crest, and the inner surfaces of your lower ribs, it acts exactly like a built-in biological weightlifting belt. Unlike the obliques we just talked about, the transversus abdominis doesn't directly move or flex the trunk itself. It just vigorously compresses your abdominal contents to increase pressure. It is pure 100% structural support. Okay, so let's take a second to compare those 3 lateral flat muscles we just unboxed, the external oblique, internal oblique, and transversus abdominis, with the vertical muscles. While the flat muscles are busy wrapping around your sides in 3 distinct layers, the vertical muscles sit squarely in the midline of your body, forming the front wall of your core.
Which brings us to the next section, the vertical muscles.
Ah, the famous rectus abdominis. This part is constantly misunderstood. So many people think of this purely as a six-pack that's just there for visual show. But structurally, it's a long, paired muscle running the entire length of your anterior abdominal wall. It's an absolutely vital engine that tenses your core, protects your internal organs, and heavily drives forced expiration.
Looking closer at the structure, the rectus abdominis is separated straight down the middle by the linea alba. And you know that segmented six-pack look? That's actually created by these transverse fibrous bands called tendinous intersections. The muscle itself originates down at the pubic crest and reaches all the way up to insert into the costal cartilages of your ribs and your sternum, working to flex your vertebral column.
Now, check out this fascinating bonus detail. Just superficial to the lower section of the rectus abdominis, there is this tiny, surprising little triangular structure called the pyramidalis muscle. Fun fact, not everyone actually has this muscle. But when it is there, it adds just one more specialized layer to the core.
The base of the pyramidalis attaches firmly to the pubic bone, with the apex of the triangle pointing up and attaching directly into the midline. It has one incredibly specific, simple job: to tense the linea alba. It essentially acts as a tiny, highly precise anchor for the very center point of your core.
So, how does all of this actually tie together? Let's talk about the linea alba.
All 5 of these muscles have to meet somewhere, right? Well, they meet at the linea alba. You can think of the linea alba as this powerful central zipper that runs all the way from the xiphoid process at the bottom of your sternum straight down to your pubic bone. It masterfully takes all those flat tendon sheets, the aponeuroses from the external obliques, the internal obliques, and the transversus abdominis, and fuses them together into one incredibly strong central seam.
Let's quickly summarize the big takeaways from this explainer. You've got 5 specific muscles that make up your anterolateral abdominal wall. 3 of them are flat lateral layers, providing that cross-ply support, and 2 are vertical midline muscles. They all fuse tightly at the linea alba, functioning together as both a dynamic biological pump and a protective corset that supports literally every move your body makes. So I'm curious to hear from you. Which of these 5 abdominal muscles surprised you the most today? Was it the crisscrossing layers of the obliques? Maybe that tiny optional pyramidalis muscle? Or just learning what your rectus abdominis actually does behind the scenes? Drop your thoughts in the comments below. And hey, if you found this breakdown helpful, be sure to subscribe for more simple, straightforward medical explainers. Thanks for hanging out with me on The Explainer.